My name is Marcelo Zambrana. I'm from Bolivia, but I live in the United States now. I am a software engineer at Microsoft. I am a big fan of DevOps, automation, data and AI, and pretty much everything related to cloud technologies. Today, we will dive into automating complex data analytics environments using tools like Terraform, Terraform Cloud, Ansible, and GitHub Actions, among others. We will explore how these technologies work together to streamline provisioning, configuration, and hopefully eliminate some repetitive tasks, freeing us to focus on what truly matters, which is analyzing our data. Since I only have a few slides, let's breeze through them to make room for the demo and some cool code I have today. By the way, all the code you will see will be available in my GitHub account at the end of the presentation. As you know, data analytics environments in the cloud have become indispensable for organizations seeking to extract actionable insights from their vast amounts of data. These environments, while offering unparalleled scalability and flexibility, often come with lots of complexities and a unique set of challenges for organizations. Integrating multiple data sources, managing different workloads, ensuring data security and compliance, and optimizing resources utilization are just to name a few. While it might be true that data scientists often focus on the functionality of the infrastructure rather than its construction, this isn't necessarily ignoring or disregarding it, but rather its natural focus shift based on their expertise and goals. Again, their primary objective is extracting insights from data, analyzing trends, and building models. Understanding how the underlying infrastructure is deployed and configured might not be directly relevant to their immediate goals. And we all know that manually building these complex environments can create tons of issues down the line, impacting scalability, maintainability, and security. Can you imagine scaling these environments manually? It will require repetitive tasks, which will increase the risk of human error, which will lead to configuration drift. Manual changes over time can lead to inconsistencies and drift in configurations, making it difficult to manage and troubleshoot issues. It will also lead to documentation gaps. Documentation might not keep pace with manual changes, causing confusion and knowledge gaps for future maintenance. Lastly, crafting a well-configured environment demands significant time. It is an iterative process that requires adjustments based on specific needs and usage patterns. Overall, as always, I think automation emerges as a crucial solution to these challenges. With that background, I would like to try a new approach. How about if instead of doing infrastructure as code, we try doing environment as code? Can you see how everything changes? The idea is to have everything that is needed for the whole architecture to work together. That means the whole cloud infrastructure, networking, subnets, security groups, VMs, etc., and all the post-provisioning configurations. It will be flexible enough that it does not matter if we are doing stream processing using Kafka, or if we are automating batch processing by loading a bunch of files from a storage account into a data lake or Hive. Even having the initial code that will connect to these data sources and start ingesting, preparing, and analyzing the data will be included as part of the initial deployment. So let me show you how all these will work. So before we jump into the code, here are some conventions I have. I like to optimize, and the less keys I type, the better. And also I hate typing because when I type, I make mistakes. So I'll be using these shortcuts and aliases as I show you the demo. With that, demo time. So let's start here. This is our folder structure. As you can see here, I'm going to explain this in more detail. I have an Ansible folder for everything that is post-configuration stuff. I have infrastructure, I have Azure and Databricks in two different folders, mostly because you can deploy Databricks anywhere. I have notebooks. Those are the Python, SQL, and all the code we're going to use for the demo. And let's start. So right now, as you can see, this is not even a Git repo, and there is nothing here to see. So we are also gonna use empty subscription that I got, and we're gonna push everything to GitHub for automation. So let's get in it. Now if we get the status, you can see this now an official repo. We are gonna add everything. We're gonna do my first commit, right? So that's good. We are also gonna create a repo in GitHub, and you can see here we just created that repo, and if we refresh this, it is here. And we can even do GitHub repo view, and this is the same. It's just an empty repo right now, and we can get into it if you want to go through the UI. What I like to do is we're going to create a prod environment so I can show you some cool configurations. We're going to add some reviewers to make sure they get approved before we merge into production. We are also going to restrict to just specific branches. In this case, we're going to select main. Right? And we come back to code. Next, we can add this remote to this repo. Now we're gonna set some secrets. Right now, probably we don't have any secrets. No secrets found. What we're gonna do is we're just gonna set some secrets so we can connect to Azure and to the streaming source we're gonna use. Right, and we do git secret, hit one, but we do git secret for our prod environment, we get more secrets. So that's good. And right now we do git st, and at this time we can push all our changes to GitHub. And if I am able to type my password correctly, it is there. So now we can do a GitHub run watch, and this will trigger our first automation. And we can follow this here in the command line, but also we can do it in the UI. I like in the command line because I like the UI, how it gets rendered. But we can also see it here. So that first commit triggered pretty much everything. And right now, as you can see, it already is on the Azure infrastructure. First, we did some static code analysis on both the Databricks and the cloud infrastructure to make sure it is okay. And then we have our first gate, which is deploying the actual infrastructure. So here we can just apply and review. Looks good to me. I can approve these changes, right? And we can also follow that here in the command line, which is great. I like that, how they sync between web and command line. While this is running, I want to show you some code, some files that I think are very interesting to see. The first one is and we have the same infrastructure here in VS Code, right? So right now I'm using Terraform Cloud to have remote states, and we can collaborate. I am pinning the version to the latest one I have. And right now for the infrastructure, I'm using the Azure RM provider, right? And I'm also deploying a VM that's going to be used for Kafka, so we can do stream processing. And once the VM is completed, I'm using the provisioner in order to execute the Ansible code that's going to do all the post provisioning configurations. And this is just a sample, so we can see how we can integrate Ansible and Terraform. This could be easily be a managed service like HD Insights in Azure that gives us a managed service for Kafka, and we can use that. Well, I thought it was going to be cool to show how Terraform and Ansible integrate very well. Moving on to the Databricks part of the code, it's pretty much the same. I'm also using Terraform Cloud. I'm using a different workspace, but I'm using the same project, as you can see. But here I'm using both providers. I'm using the Databricks provider, and I'm using the Azure RM provider. The reason I'm doing that is because once the Databricks workspace gets created, I'm going to use that data in order to initialize the Databricks provider, so the authentication is seamlessly done by the providers, right? I don't need to provide any tokens or anything, or create tokens in the Databricks workspace. So it's going to use the information it already has from the Azure RM provider into the Databricks provider. And along with that, on the Databricks, I'm deploying some notebooks. This can be seen here in this notebooks folder. For this demo, I'm going to show two types of projects. One is going to be stream processing using Kafka. It's going to connect to an FAA data source, which is a stream. I think I did a presentation about that a couple of Hashi talks ago, when we connect to FAA and start analyzing flight data, right? So it has multiple data sources. Right now, I'm just using 3. And at the same time, I'm going to show how we can automate batch processing using Databricks workflows. So for that, I'm going to be using a data set of songs. We're going to ingest songs, analyze them, prepare them, and get the top songs created, the most songs created by artists every year, for example. I think that's the sample we're going to use. So in parallel, we're going to do both. We're going to do stream processing, and we're going to do batch processing, automated batch processing, right? And these are the notebooks we're going to use for that. And here we have the workflow we're going to define in Databricks. So we have the notebooks we created notebooks, but here we are going to define tasks using those notebooks so we can automate the whole pipeline. We are going to ingest the songs. We are going to prepare the song data, and then we are going to analyze the data. So here I'm just creating the task that is going to allow us to automate the whole process. And of course, this is the GitHub Actions configuration. Oh, sorry, this is the Ansible configuration. So, and again, this is just to show how we can integrate Terraform and Ansible. So once the VM is created, I'm using this Ansible role to configure everything that is required for Kafka to connect to a stream. Kafka requires Java, so I'm installing Java. I'm creating some groups dedicated just to Kafka. And I'm installing and creating some configurations and copying some jars, dependencies, configuration files, all that stuff. And everything is done with Ansible. Finally, this is the GitHub action workflow that we are using. Defining some secrets. As you can see here, I am using reusable workflows, so we can do a static code analysis. I also did a presentation on how to use reusable workflows in Terraform. I think that was last year's Hashi talk. So I can reuse these workflows from different repos, right? I'm building the infrastructure, and then I'm doing also the Databricks configuration. So before getting into a little more detail, let's see how our pipeline is going. So as you can see here, already finished the Azure infrastructure. So right now it's moving into the Databricks part. So again, for this part, I can also review the deployment. And if I like it, I can just, it's good to me. And I'm going to approve this and then start deploying the Databricks part of it. And probably by this time, we can see if we go to the Azure portal. Let me increase a little bit more. You can see that we have the resource group with everything that we are going to use, right? The workspace is here. The Kafka VM is here. The VNet we're going to use is here, and what I like here is we are using some multiple subnets for multiple workloads. These two are dedicated to Databricks. So along we are building the infrastructure, we're also applying some best practices, like having tags properly done in all the resources, right? All the subnets, security groups, all that stuff that are best practices when you deploy this kind of resources, right? So right now it is deploying everything that is related to Azure Databricks, and we can probably see here the same in the command line, right? So going back to code, as I was saying, this is the GitHub workflow that we're using to build this whole environment, right? We are encapsulating everything that we need to build this environment and automate it in just this project, right? We have all the underlying infrastructure, all the post-provisioning configuration scripts, all the Databricks resources we're going to use, the cluster, the notebooks, the workflows, everything that is required, right? So everything is just one environment as code. So if we go back to here, as you can see, it's applying. It usually doesn't take a lot of time. And if we go to here, we can see that's pretty much done. So it took some time, but it finally finished. As you can see, the whole pipeline is green, and yeah, it finished applying everything. If we go back to the portal, we can get into the Databricks workspace. And the good thing is that since it is deployed within Azure, it's single sign-on. You don't need another set of credentials. Now let me make this a little bit bigger. I think that's good. So let's start with the compute. We just created a cluster. As you can see, this here is just a small cluster for testing. We also make some configurations to make sure it is properly configured. Right now it's just min 1 node, max 2. We also enable auto scaling, and we also enable auto terminate after 25 minutes of inactivity, right? So we also imported some libraries, Spark XML, that we're going to use for the streaming part of it. And here are the workflows that we were talking about. So this is the songs workflow. This one is going to automate the batch processing. As you can see here, it's going to ingest, prepare, and analyze the data. We can run it right now. We can view the run. So right now it is executing each of the notebooks we deployed using Terraform, which is really cool. While this is running, we can also go to the workspace. Here we deploy all the notebooks here, as you can see, in folders, organized. Right now it is doing the ingestion. As you can see here, it's just getting one of the sample data sets that Databricks has about, in this case, songs. Then it's gonna prepare the data. So once it is ingested, it's gonna create some tables. And once it's finished doing that, it's gonna analyze, right? It's gonna, in this case, it's gonna get which artists release the most songs each year. So if we go to the workflows, and you will see it just finished. Oh, it's still running. Like with a couple more minutes. But meanwhile, we can see the catalog, right? Because right now, everything that is doing right now is being ingested here into Hive Metastore by default. And while it is doing that, we can also dig into the streaming part of it. So right now we have a Kafka server, as you can see here, and it's using internal IP for security. And we can connect these to the same cluster, and we can connect to it right now. So as you can see here, it's going to run the command. This first set of code, the only thing is just giving us the schema. of the messages we're gonna get. It's gonna have a key, a value, a topic, all that stuff. So in this here, we are just getting a sample of the messages that we're getting from Kafka. And here it was kind of fast. And all of this is XML. That's why we imported the XML library right into the cluster. And all of this is just flight data that we are ingesting from FAA, the stream, from this service, TFMA. And here you can see the airline, the tracking information, the timestamp, it's a jet, it's a commercial aircraft, things like that. So all of this is just heavy XML. That's why, in order to help data scientists analyze this, we also imported the Spark XML library. So at this point, probably the workflow finished, as you can see here. Everything is green. If we go to the last one, we can get the output, right, that we were expecting, which artists release the most songs every year. So this is just one data set that we imported, where we can keep piling all those files, and this will just automate the whole flow. And as you can see here, we have the results, right, and everything automated. And if we go back to the catalog, probably here we have the per person data table that we created, and the rows song data that we imported. And we have some sample data here as well, right? And in per person, probably the data is a bit massaged, right? The columns, duration, things like that. So that's really neat. So from here to here, we have the whole automation and creation of the whole environment, right? That supports streaming and batch processing in an automated manner. A couple of other things I want to show before we go back to slides. Again, all the configurations are standardized, naming convention, tagging, all that stuff is properly configured. If you go to GitHub Actions, the flow is there, green, and probably you also get a green badge that is passing, right? So that's really cool. And if you go back to the CLI, again, yeah, this finished, as you can expect. And the cool thing is that since we are using Terraform Cloud, we can easily do Terraform output from here, and we also can get the results from the command line too, right? We have all the information about the environment that we just created. We can probably do the same for the Databricks provider. If you have any outputs, in this case, I think it's just cluster information that it is running, right? That's thanks to have Terraform Cloud and using remote state. So I think this is a good point where we could just hand over the environment to the final users, in this case, the data scientists, or whoever is going to work on this environment, right? Let them write all the code they're going to need in order to improve and get insights about the data. So we went from pretty much nothing to a workable environment in like between 15 to 25 minutes. I think that's pretty cool and acceptable, right? And everything as code and automated, right? We have barely any manual intervention of everything. Once we pushed the code to GitHub, everything was automated. So going back to slides. Okay, going back to slides. So putting it all together, we basically saw this flow where everything starts with developers and having everything as code, right? And this idea of version control and being able to see the changes that were made to a particular file or files, when and who made those changes. With this combination, everything as code and version control, it is easier to distribute the work and collaborate. And the benefits that gives when you have your environment as code is that you are not just able to say what is currently being deployed, but being able to repeat it and see how it was deployed a week, a month, a year ago. And since it is code, you can easily apply development lifecycle principles and, of course, CI/CD pipelines, as we saw in the demo. Just to call out some specific parts of the code, and here we saw how easy it was to use Terraform Cloud and specify the provider we're going to use, in this case, Databricks and Azure RM. Here we saw how it's easy to integrate Ansible to do all the post-provisioning tasks, right? And this could be Chef or Puppet or some other configuration management tool. In this case, I just chose Ansible. Here we see how to use the Databricks workspace resource from the Azure provider. And once the workspace is created, we use the Databricks provider to connect to it and create Databricks specific resources, like the cluster itself, the initial notebook that we saw, the tasks for the workflow, import the libraries that we're going to use, pretty much everything. Lastly, we also saw the manual approvals and gates in GitHub Actions before we roll out changes to production. I think this is a really good practice, right? And GitHub Actions give us this functionality really easy. Some key takeaways. I think in conclusion, the answer is clear and evident that automation plays a pivotal role in this context. It enables seamless deployment of complex environments, as we saw, leveraging code to ensure that you can replicate the deployment across multiple platforms or anywhere you need it, basically. Imagine setting up disposable environments for rapid testing or research, then seamlessly integrating successful configurations into your production or primary environment upon successful validation, of course. Automation and cloud computing are changing the game. Right now, data scientists are increasingly involved in infrastructure-related decisions as automation empowers them to manage and configure environments themselves. So maybe having environment as code is not such a bad idea after all. On the tooling part, integrating and mastering multiple automation tools like Terraform, Ansible, and GitHub Actions could require training and ongoing maintenance. That's true. Still, it is amazing the things you could achieve when you integrate all these tools together. Thanks to GitHub, you have version control, so you can review historical changes and revert them back if it's needed. You can also have manual approvals and gates, as we saw again, before changes are applied to production or to a specific environment for that matter. Almost to the end, here are some resources if you want to dig deep and expand. The Databricks Terraform provider also has tons of examples and even modules that you could reuse. Terraform modules, of course. Sadly, right now, it does not support OpenID Connect with GitHub, which is really sad. That's why I put the issue there, so you can go comment and like it, so they can make it a priority, so we can have it there. It will be really nice. With that, I just want to say thank you. I really enjoy doing these hands-on demos. Hope you enjoy it as well. If you have any questions, feedback, or just want to keep in touch, here's my contact information. As promised, all the code I showed today, it is available in my GitHub account right now. As we saw it, we built it together. And again, this new concept of environment as code probably is not such a bad idea. Finally, thanks to HashiCorp for this amazing opportunity and the whole team that make this event possible. Thank you so much, and until the next time. Ciao.